On an autumn morning, the interior of the massive hangar at Shanghai Pudong International Airport is silent. Sunlight filters through the stainless steel framework, glinting off the surface of an unfinished fuselage. This is the COMAC C939, China's response to the Boeing 77X and perhaps the future of aviation. But today, the assembly line is almost at a standstill. No cranes move across the floor markings. No sound of torque wrenches. Because this aircraft is more than just metal. It is a challenge to the commercial aviation status quo. At first glance, the C939 looks like an ordinary wide-body passenger aircraft. With a capacity of 400 passengers and a range of 14,000 kilometers, it promises to fulfill China's long-range dreams. But beneath its outer shell, this aircraft carries a silent revolution. Just like the C9 19 years ago, the C939 is not merely an engineering project. It is a new chess move that will determine who will rule the skies. Now is the time to ask the question, can this aircraft really fly? Or does its fate echo that of the C919? If I told you that in the 21st century, an aircraft flies not only with its engines but also with political balances as delicate as fingerprints, what would you think? COMAC, which combines American technology and Chinese ingenuity, began developing the C939 in 2016. The goal was clear: to create an alternative that would challenge the dominance of the Airbus A350 and Boeing 777X. But Chinese engineers knew this well. This was not just an engineering project, it was a test of strategic independence. Initially, the project progressed as swiftly as the C919. The C939 was designed to be equipped with Western systems. The LEAP XG engines, developed by the GE and Safran partnership, were selected. Cockpit systems, Collins Aerospace, flight control systems, fuel management, hydraulics. All components were sourced from reliable, tested Western suppliers. Have you considered why? The answer is clear. COMAC wanted to get this aircraft off the ground as soon as possible. But at this point, an ironic twist begins. Because 55% of the aircraft is made up of imported materials, and nearly all of that import comes from American companies. When Washington's foreign policy changes, the permits for those engines can vanish with a single signature. And what was done for the C919 in 2025 begins to cast a shadow over the C939. According to high-level sources, the C939's engine licenses have been integrated into a case-by-case review system. This makes American approval mandatory for every new delivery. Don't think of this as just one part. It means tying the fate of the entire production line to an email in Washington, D.C. Imagine an airplane made up of 4,000 parts, but the production license is tied to a single-line document. So, do you really think this is a triumph of engineering? Or is it an illusion under the shadow of political will? Beijing has long recognized this risk. That's why it developed a new design for the CJ1000A for the C919. Now, it has launched a new engine project led by AECC for the C939. This project is called Yunlong. Tests for the Yunlong engine are still ongoing. The first prototype is reported to consume 8% more fuel than the LEAP XG. But this is not new for China. The CJ1000A engine, which serves as a backup for the C919, also faced similar issues. And Beijing's message was clear: we fly first, then optimize. However, engine design alone is not enough in the aviation industry. Flight certification must also be obtained. In particular, EASA or FAA approval is one of the most important factors that will determine how competitive this aircraft will be worldwide. For this reason, political barriers are more challenging than engineering challenges. China has accelerated its efforts. China has launched an emergency investment package of 160 billion yuan. to equip the C939 with domestic components. This amount was originally planned to be spent over 15 years, but it will now be allocated over just 5 years. The silence inside the hangar was not a sign of an engineering problem, but a political message. The nose of the C939 was still covered in plastic. Radar reflector tips had not yet been installed on the wingtips. However, in the middle of the fuselage, a massive fuel line extending into the cabin was shining brightly. That line is not just a tube. It is the strategic artery running through China's fuselage. So, what makes the C939 so critical? Let's start with the basics. This aircraft will be the first Chinese-made model in the wide-body category. It is expected to have a capacity of 280 to 320 passengers. The maximum range target is 12,000 kilometers. In other words, this project is sending the message: we are no longer just flying within Asia, we are charting transatlantic routes. This is where the first breakthrough occurs, because flying transatlantic requires not only powerful engines, but also compliance with Western regulations. If authorities such as EASA and FAA do not approve an aircraft, its global commercial value is close to zero. This is precisely why the C939's interior is much more significant than its exterior. The wingspan of a Boeing 777X is 71.8 meters. The C939 is reported to be around 68.5 meters. This difference shows us what China cannot yet do, but perhaps the answer lies in the word yet. At the heart of the aircraft will be the CJ2000 engine developed by AECC. It may consume 10% more fuel than the LEAP-1C, but Chinese officials have repeatedly stated that this is only the first generation. Let's consider this question. Would you prefer a cheaper aircraft that consumes more fuel? Or a more expensive but globally accepted model? The answer to this question is quite difficult. This is because the price of the C939 has not been fully disclosed. However, figures circulating in the industry suggest that it will be between $25 million and $30 million. This is almost a third of the estimated price of the Boeing 777X. The turning point in the story lies in the fact that the parts are domestically produced. It is still unclear how much of the C939 supply chain remains within China. An airplane consists of 4,000 parts, but production approval sometimes depends on a single line in a document. An email sent by Washington one morning froze the entire assembly line. The only way for the C939 to avoid the same fate is to establish a 100% domestic system. And this is where the story shifts from technology to strategy. While the CJ2000 engine has not yet entered body testing, information notes from Beijing indicate that certification processes are targeted for completion by 2027. However, this timeline is political, not commercial, because if another U.S. sanction is imposed by 2027, it could affect everything from engines to cabin climate control systems and radar altimeters, so they are no longer just testing an engine, they are also testing a doctrine of independence. A Shanghai-based assembly worker commented on the matter. The wings of this aircraft are made of carbon fiber, but the adhesive is political. The Phoenix Integrated Avionics Suite will be China's first domestically produced wide-body cockpit software. However, it is not yet advanced enough to support RNPAR approaches. This means it cannot fly to Europe or the US. Today, China wants to approach the West both physically and symbolically with the C939. But every cabin button, every flight computer reminds them of how dependent they are on the West. In the next section, I'll take you behind the scenes of the first test flight. And there we'll see, this isn't just an engine start. It's a national message broadcast. And at that moment, it won't just be engineers watching the runway. The countdown to China's biggest secret is also beginning at Pudong Airport. Although the C939's first flight was presented by state television as an aerodynamic celebration, behind the scenes, this test flight means not just aerospace engineering, but a strategic nerve test. When the aircraft touched down, it wasn't just cameras watching. Western intelligence agencies were scrutinizing every signal, from radar tracks to avionics data streams. Because the C939's flight signifies China's superiority, not only in engineering but also in politics. The Phoenix cockpit system is still pending. This means that the autopilot systems are limited and emergency protocols are manual. For this reason, retired test pilots from the People's Liberation Army Air Force are on duty for the aircraft's first flight. Because this is not a civilian flight, this is a controlled demonstration. The purpose of the demonstration is clear. You cannot exclude us because we are creating our own air ecosystem. However, what is seen from the outside differs from what is happening inside. The CJ2000 engine exhibited vibration deviations at low RPM levels during the last test. The turbine temperature is still very close to the critical threshold. This situation affects not only performance but also the insurance and certification processes. For a Boeing aircraft, such an issue can be resolved in a short time. However, for a C939, the same problem could undermine the reliability of the entire program. That is why China's top aircraft manufacturers are not just engineers today, they are also acting as crisis managers. The CEOs of Airbus and Boeing made statements to investors. A successful first flight for the C939 is not about sales, it's about perception. If China can indeed obtain certification from the CAAC, EASA, and FAA by 2029, then the C939 will not just be an alternative, but a threat. After what happened with the C919, leasing companies are now pursuing a policy of cautious optimism for the C939. Can a country really build its own sky with a single aircraft? This question concerns not only China, but all other countries as well. Do you think a country can declare an aircraft produced with imported engines as domestic? In the last section, I will take you to scenarios after 2026. If the C939 is successful, in what direction will the aviation sector evolve? And what if it fails? This will be a story written not only in the sky, but also in strategy. The C939 recently completed its first flight. While China celebrated its success with enthusiastic press releases, the global aviation world remained silent, asking the question, can this aircraft really fly? The C939 is still more than 30% dependent on Western countries. Every shipment is a diplomatic gesture. Every spare part is a strategic risk. If diplomacy works, China will make some promises on technology control, and in return, engine and software exports will resume. The C939 will enter production under these conditions. However, every production line operates under an approval list. Now, the production story of every aircraft is being carried out in a way that is dependent on the West. The real question is, in this situation, will the C939 truly be a Chinese aircraft? Or will it be an American-French project assembled in China? If the CJ2000 engine obtains these certifications in 2027 and the Phoenix avionics meet European RNP requirements, China will be able to fly beyond its own airspace for the first time with its own engineering. If this aircraft is entirely domestic, will Western countries allow it to fly in their skies? Even today, COMAC's order backlog is quite substantial. However, 90% of these orders are from Chinese companies. Because the issue is not just performance but also spare parts security and resale value, among many other criteria. The story of the C939 is essentially an effort to break free from the shadow of the C919. China is not just building this aircraft to sell it, it is building it to establish an aviation ecosystem. Establishing this ecosystem is not just a technological challenge but also a cultural one. The story of the C939 is still being written. However, aircraft are no longer just flying in the sky, they are also making their way into history.